mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
Good morning, grade 11s. Welcome to Friday morning, May the 15th. And today all we're going to do is I'm going to go over some of the questions that you gave me via email on the assignment that came out of your textbook. And then later today the test will show up on Connect as well, and you will have until next Friday to complete that test. And that test will be on everything that we've covered on waves so far. So I believe we started that on April 23rd, 3 weeks ago. And so anything in the last 3 weeks will be on that test, from general wave behaviors to how waves behave around barriers, those ideas of reflection, refraction, diffraction, so on, to the things that we're doing here with Doppler effect, the speed of sound, Mach numbers, and of course the music stuff that we've been covering the last couple of days. So that's what you can expect. And again, you have a full week and it's open book, and so use all the resources, go back, check things out, and you'll have lots of time to finish that test. Starting next week, we're going to move into, again, continuing on with a waves theme, but we're going to focus on light. And light, as we'll learn, can be a wave, and so we're going to look at the properties of light when it is acting and behaving as a wave. So to start with today, we're going to go over question 68. Now, question 68, I feel, was a question that actually left out a little piece of information. You had to assume something that wasn't there. Question 68 has a fire truck moving at 35 meters per second and a car in front of it moving in the same direction at 15 meters per second. The fire truck sounds a 327 hertz sound, and we want to know what the frequency that the car hears. All right, so we're going to use our Doppler effect formula, right? We have two moving sources, or a moving source and a moving detector, and so there's going to be a Doppler effect that's taking place. So the information given is that the frequency of the source, Vs, is 35 meters per second. That's the truck. The truck is making the sound, so it is our source of the sound. The car is our detector, so the velocity of the detector is 15 meters per second. The frequency of the sound was 327 hertz. This velocity of sound was not given in the question, so you have to make an assumption that we're just going to use the generic velocity of sound at 20 degrees Celsius, which is 343 meters per second. On page 406 of your textbook is a chart of some various speeds of sound that we can use whenever a speed of sound is not given in a question. All right, so we're going to use 343, which is at 20 degrees Celsius. Our formula again for Doppler effect is here: Fd equals Fs times V minus Vd over V minus Vs. Again, remembering that the V without a subscript is the speed of sound, Vs is the speed of the source. All right, plugging our numbers in: 327, 343 minus 15 over 343 minus 35. Punch that into your calculator and you get a frequency of 350 hertz. So there you go. That's how we do that question. We will do another question on the next board. All right, the second question that I received was question number 78. And again, I feel that we probably could have avoided this question had the velocity of sound been given in the question. But again, in this question, we're told the frequency of the sound is 16.4 hertz. And if we use the velocity of sound at 343 meters per second, the question is, what is the shortest open pipe that will resonate at this frequency? In other words, what's the first resonance frequency for this scenario of an open organ pipe? So the first thing we're going to do is we're going to find the wavelength. So again, wavelength, velocity over frequency, 343 over 16.4 gives us 21 meters, rounded to the nearest whole number. All right, and again, now because it's an open pipe, the first resonance will happen at 1/2 the wavelength. And so that will happen at 10.5 meters. All right, so a relatively straightforward, simple question. If you remember where the first resonant frequency of an open pipe happens, which is always at 1/2 the wavelength, and if, of course, we had been given the velocity of sound, we've been able to gotten that. Part B is a thing that I thought the question was asking something different, but it's actually asking something that I didn't show you, so you can forget about part B, and we'll just move on without it. Okay. So to finish off today then, what I'm going to do is we're going to go backwards a little bit. I was asked a couple questions a little later in the day, and so 52, 53, and I can't remember what the other one was, 50 something. Give me a sec, I'll be right back. '52, '53, and '59. And I think that the problem in the question comes in the fact that you're not given velocities of sound. And so as I said earlier, page 406 has a chart of velocities of sound. And I'm going to say this, unless otherwise stated, we're going to assume that the temperature is 20 degrees Celsius, which means that in both question 52 and 53, your velocity of sound is 343 meters per second. And so you're trying to find a distance, for instance in question 52, where it says you hear the sound across a canyon, or you hear the sound of the firing of a distant cannon 5 seconds after seeing the flash. How far from you is the cannon? And so you're hearing a sound 5 seconds later than what you are seeing the flash of it. All right, so that means that we have a velocity, so this is question 52. Again, we have a velocity of 343 meters per second. Again, that's not given, and whenever we're not given, we're going to assume it's 20 degrees Celsius and a velocity of 343. And our time is 5 seconds, and so we're simply doing distance equals velocity times time. You're going to do 343 times 5 seconds, and you're going to get your 1,700 meters, or 1.7 kilometers. All right. Same thing happens with 53. If you shout across a canyon and hear the echo 3 seconds later, how wide is the canyon? Now, what you have to remember for that question is that you're shouting from here. You're shouting from here. The sound is traveling to the far side and back, and that's taking the 3 seconds. So when you find, you're going to use the exact same thing you did here. You're going to do 343 times 3 seconds, but that is going to be 2 times the distance, so you're going to have to divide by 2 at the end to get how far it is just one way. All right, so then if you do that, you're going to do 343 times 3, and then you're going to divide that by 2, and that will give you your answer of 510 meters. Okay, and for question 59, the same kind of thing happens. It's asking you to, it says a sound with a frequency of 442 hertz travels through an iron beam. Find the wavelength of sound in the iron. And again, the velocity of the sound is not given, but in that chart on page 406 of your textbook, there's a speed of sound in iron, and it is 5,130 meters per second. So for us to find wavelength, we're going to do velocity divided by frequency. Take that velocity, divide it by the 442, and you will get the 11.6 meters. Okay, that's it for today's video. It's just some answers, some solutions to the questions you've been doing. I want you to continue working on that. I will be posting the test today as well, but please continue to ask your questions. I'm only posting the test today, so those of you that are at this point and feel good and confident can start it. You will have until next Friday to hand in that test, so you got lots of time. Yeah, continue to ask me your questions between now and the due date. So if you're still working on some stuff and you have questions, ask them. If I can respond by email, I will. If not, I'll make a video and I will push it out to you at that point. All right, so it's the long weekend. Enjoy your long weekend. The weather's supposed to be beautiful, and we will see you on Tuesday. Have a great weekend.